All right, so let me quickly do a recap because of that session. So we started with a subtopic on oxidizing and reducing agents. And we said oxidizing agents, they are agents, just like we have house agents, that they ensure oxidation is happening to a species. And they themselves, they become reduced as they are ensuring that oxidation. For example, last week we said oxidation is loss of electron, oxidation is gain. Oxidation is gain of loss of electron, gain of oxygen, and loss of hydrogen. And we said reduction is gain of electron, loss of oxygen, and gain of hydrogen. So in some chemical reaction, there are some agents that ensure oxidation proceed. There are some agents that ensures reduction proceed. So any agent that causes oxidation is, once you see that an agent is causing oxidation, we refer to them as oxidizing agents. Now, how do we know these agents? They themselves, they will become reduced. So any species that is reduced is the one causing oxidation. So we refer to them as oxidizing agents. Is that taken? And to the reducing agent part, they are the agents that causes reduction. So they themselves, they become oxidized. So anytime you say reaction, any species that is oxidized itself, oxidized simply means probably it has gained oxygen or is losing electron, is what we refer to as the reducing agent. Please, do we get that concept? So it is very simple. So look at this example here. We have Fe reacting with copper 2 plus to give Fe2 plus and copper solid. The oxidation number for Fe is 0. This one is +2. It simply means that iron has lost 2 electrons, isn't it? In valency, when you see positive charge, it simply means it has lost some particular number of electrons. And when you see minus, it simply means it has gained electron. So from 0 to +2, it simply means iron has lost 2 electrons, right? So iron is losing electron here to become Fe2 plus. And what is happening to copper? Copper is gaining electron here. Copper is gaining electron here to become copper solid, from copper ion to copper solid. Now, looking at the law that I give you here, you can simply say that iron itself is being oxidized. Please, are we together? Please, can you all hear me? We can say iron itself is being oxidized. Why? Because it is losing 2 electrons. So because it is being oxidized now, they are not asking for which one is oxidized, which one is reduced. They are asking for reducing agent and oxidizing agent. But for the fact that we know that iron itself is being oxidized because it is losing electron here, it's losing 2 electrons. Therefore, iron is a reducing agent because it's causing reduction. For this copper 2 plus, you can see copper 2 plus here is gaining extra 2 electrons to become copper solid. They get the concept. So if you want to know oxidizing agent, reducing agent, the best thing you need to do is to know which one is losing electron. The one that is losing electron is the one that is being oxidized, and it is the one that is the reducing agent. Did I come again? The one that is losing electron is the one that is being oxidized, and it is the reducing agent. The one that is gaining electron is one that is being reduced, and it is the oxidizing agent. Should I write it out? Is it taken? For example, now if you look at iron here, iron is the one losing electron. Iron is the one being oxidized. Therefore, iron is the reducing agent. Do you get it? And if you look at copper 2 plus to copper, so it's the one gaining electron. Copper 2 plus has gained 2 electrons to become copper solid. So it's one gaining electron. Therefore, it's the one being reduced, and it is the oxidizing agent. Please, do we get that concept? So it is very simple. So the easiest way for you to just get the oxidizing, the reducing agent is know which one is oxidized, know which one is reduced. The one that is oxidized is your reducing agent, while the one that is reduced is your oxidizing agent. So you can see here, you can say iron became iron 2 plus, right? So if iron become iron 2 plus, therefore that's lost electron, lost 2 electrons. Okay, let's say lost 6 electron. And because it lost electron, if you remember what I gave you oil rig. Just to remember, I say oxidation is loss of electron, and reduction is gain of electron. And reduction is gain. So since it has lost electron, simply means it has been oxidized. And since it has been oxidized, we can easily say that it is the reducing agent. It is the reducing agent. Please, do we get that? Now, if you look at the second one here, which is uh, our copper. So copper 2 plus change to copper solid. So it simply means it has gained how many electrons? That's 2 electron, I mean. There is gain electron. So we said reduction is gain of electron, isn't it? So it simply means that this is the one that is being reduced. And anything that is being reduced is the oxidizing agent now. Please, do we get it now? Gift, do you get it now? Okay. So that's it. Lillian, do you get it? Are you guys clear with it? Can I proceed? All right. Let me give you one example more before we move on. Let's check Cl2 plus Br minus giving Cl minus plus Br. Now this is not balanced, so the first thing you need to do is to balance it. Linear, can you balance this for us? Can you balance this equation? Lillian,
Sir?
balance this equation for us, please. Hello, are you there?
Yes, sir.
Did I continue? I think we should balance it for me. Oh, balance it for us.
I'm writing it down.
Lina, what do you say?
I want to write it down.
I want to write it down. Okay, we are waiting. Lilian, we are waiting. Cl2 plus 2Br minus plus 2Cl minus plus Br2. Yeah, so we add 2 to the Br minus here. And we add 2 to the Cl minus here. Yeah, this is balanced. So now they want us to look for the oxidizing agent and the reducing agent. Some question we ask for four things. They will ask you which one is oxidized, which one is reduced. They will ask you which one is the reducing agent, which one is oxidizing agent. So any which way. But our main focus for now is the oxidizing agent and the reducing agent. Once you know which one is reduced, definitely you know that such a component is the oxidizing agent. Now let's look at this. So Cl2 proceeds to give 2Cl minus. What happens here? Minus chlorine has become negative, simply means there is gain of electron. Gains electron, right? Isn't it? And this Br minus has become Br2 from 2 minus to 0, simply means it has lost electron, because minus simply means it gains electron before. But now it has become 0, simply means it has lost the electron. So it simply means from Cl2 to Cl minus, there is gain of electron, I mean, gains electron. So if it gives electron, simply means is a reduced species. That is the one undergoing reduction. And if it's the one undergoing reduction, therefore, it is the oxidizing agent. Isn't it? And for the other one, which is Br minus, and see Br minus from 2 minus to Br2. Losses electron. And because it lost electron, that means it's oxidation, because oxidation is lost, so it has been oxidized. And because it has been oxidized, that means it is a reducing agent. I believe that is clear. I believe everybody is clear with that. It is easy to identify. Kids, can you now identify any species now? There's no more confusion of it. Now, you guys do this question. Let me see. 2Mg plus O2 giving 2MgO. Just tell us the reducing agent, the oxidizing agent. And you tell me the reasons. Nobody. Hello? Can you guys hear me? Mg is oxidized. I'm talking about O is reduced. So which one is oxidizing agent? Which one is reducing agent?
The oxygen is the oxidizing agent.
And magnesium is reducing agent.
Yes, sir.
Do we all agree? If you disagree, let me see your hand. Lillian, do you agree? Oh, Lillian, sorry. Kitty, do you agree? Is she sitting in the class or she's sleeping already? Give me confirm. Is she sitting in the class? That girl is sleeping already. Okay, so you are right. You can see Mg2. If you look at the oxidation number of Mg here, Mg so if you want to use the oxidation number, so from Mg to Mg2 plus, it simply means it has lost electron. And if you look at oxygen here, from O2, the oxidation number of oxygen here, I don't know if you know how to calculate oxidation number. This is O2 minus. So it simply means it has gained electron. So therefore, Mg is the reducing agent because it has been oxidized, it has lost electron. From Mg becomes Mg2 plus. Yeah. What you want to use in terms of oxygen, Mg gains oxygen here. From Mg it gains magnesium oxide, isn't it? And anything that gains oxygen is what has been oxidized, isn't it? So therefore, it is the reducing agent. And oxygen also is 0 to MgO. Since Mg to MgO has gained oxygen, O2 to O2 minus has gained electron. Or since Mg to MgO has gained oxygen, therefore O2 to MgO will be your oxidizing agent because it has gained electron. So you just do this as let me give you just 2 examples. Do it as assignments. Just submit the answer on the group once you are done after the class. Let me look for exam questions. Okay. Write it down now. Are you writing it? I want to write the second one. K2Cl2O7 plus 6Fe2 plus 14H plus given right to 2Cl3 plus. plus 6 Fe3 plus 7 molecules of water. So on the group, just write the equation, then tell me so species oxidized, is the oxidizing agent, and tell me the reason. And so species the reducing agent. Are you writing that?
So is it +7 on chromium?
What do you say? Is it
Is it +7?
for chromium 3 plus? 2C have 3 plus.
Okay.
Uh, you are done writing, Abby? Lillian?
Yes, sir.
Okay. So this is second example. Hydrogen peroxide giving rise to 2 molecules of water plus O2. So these are the questions JAMB asks normally. So they are past questions. So if you can identify this easily, there's no question you'll not be able to do. So these are the normal questions you ought to do after the class. But then I wanted to do it because of our time. So if I quickly write that down, and let's move to another topic. You have to be fast with this one. These rules for assigning oxidation number. Oxidation numbers. Many times they don't ask question on that list. Many times. But you can see question under it. But sometimes you need to know how to calculate your oxidation number so that you can get your oxidizing agents and your reducing agents proper. Can I guys hear me? Oxidation on oxidizing. We have rules for assigning oxidation number. Is that taken? It's number 6%. So sorry guys. So we are talking about rules for assigning oxidation numbers. So let's start with the first one, the free elements. Every free element acts an oxidation number of 0. Free element simply means any element that is not combining with another element. They always have an oxidation number of 0. Is that taken? For example, any element that is in a solid state that is not in it, is not dissociating or ionizing. For example, let's say hydrogen gas, oxygen gas, sodium, chlorine gas. All this is zero. Is zero. We call them free elements. Is that taken? So anytime you see an element that is not combining with another element, what did I say? It has an oxidation number of 0. Is that taken? The reason is because they are in their natural states, so they are not combining with another element. So they have Jesus. Sorry, let me block incoming calls. Give me 1 second. So I'm coming. Those calls are disturbing me. Sorry, give me 30 seconds. I want to block all incoming calls. Okay. Sorry for that. Okay. So I believe you get the explanation of the free element. Do you know what free elements are? Elements that are not combining with another element. We call them free elements. They are in their own natural states. So they are not dissociating, they are not ionizing on anything, and they are not combining with another element. So they always have an oxidation number of 0. How that is taken. Another thing you need to know is the monoatomic ions. The monoatomic ions. The monoatomic ions is talking about the atoms that have just one atom with a charge. Let me just put it that way. So they are just talking about one atom with a charge. So here, the oxidation number would be the charge of that ion. Let me just write it for you. So the oxidation number would be the charge of the ion. To be the charge of the ion. So if it is just one atom in that charge, so its oxidation number would be the charge of that atom. For example, let's say sodium plus Na plus. It simply means the oxidation number is +1, isn't it? Mg2 plus. It simply means the oxidation number is +2. They get it. 2 minus. Simply means the oxidation number is -2. So you don't need any calculation for this. It is straightforward. So let's go to some part. It's in that table. The table I first gave you, so I should not explain again. Do everybody understand the table?
Okay.
So for example, now oxygen has an oxygen number of -2. Look at this rule here. Can you guys see it? Oxygen always has an oxygen number of -2, but there is an exception to it. When oxygen is behaving like a peroxide, like hydrogen peroxide or any peroxide like H2O2, the oxidation number of oxygen will become -1 instead of -2. But every other oxygen, let's say normal oxygen now, every other normal oxygen is -1 or -2, while peroxide oxygen is -1. They get it. Look at this 61 here. It said hydrogen oxidation state in most of its compound is +1. unless it's combined with a metal, in which case it is -1. So it simply means hydrogen is always +1 in most compounds. For example, when you check H2O, what's the oxidation number of hydrogen? So instead of you calculating it, you know that hydrogen oxidation number is +1. H2O, for example, if hydrogen is X, that would be 2X plus the oxidation number of oxygen in most cases is -2. Except for peroxide, simply means oxygen is -2. That's 2X plus -2 equals 0. That would be 2X equals 0 plus 2. That's 2x equals 2. S equals 2 divided by 2, x equals 1. Simply means hydrogen is +1, isn't it? So hydrogen is 1 in most compounds. For example, hydrochloric acid, HCl now. Chlorine is -1, abi? So if you want to calculate for hydrogen, it will be X plus, into bracket, -1 equals 0, isn't it? So X will be equals to, when -1 cross the other side, that will be 1. These are all together. But for when hydrogen is reacting with metal, we call it metal hydrides. Hydrogen will not be +1 again. Hydrogen will not be -1. Please, do we all get it? So let's say, what's an example of metal we can use? Let's use calcium hydride, CaH2, for example. Or let's use sodium hydride. That one will not confuse you. Can somebody calculate the oxidation number of hydrogen in sodium hydride, NaH? Or mute your mic. Use mouth to calculate it. Give to your talk.
The oxidation number of sodium is 1. Yes, 1 equals to X. So the oxidation number of this thing of hydrogen. Wait, let me write it down. X plus 1 equals to X equals -1. X is equals to -1. So hydrogen is -1 when it combines with sodium.
Okay. Very good. What about calcium hydride, CaH2? What about calcium hydride, CaH2? Do you know how hydrogen is also -1?
Say calcium hydride,
Calcium hydride now.
let me calculate it.
Hmm?
Let me calculate it. I will get back to you.
You don't need to calculate it. Anytime you see hydrogen reacting with a metal, it is always -1. So that's the purpose of that table.
Okay.
You get it? But I just want you to see how they got about that table. So it's not just something somebody just hook out. It is a law. So for example, that calcium hydride. Calcium has a charge of +2, right? And we are
Yes.
looking for hydrogen. Hydrogen is that would be 2x. So if calcium go to the other side, it will become -2. That would be x equals -2 divided by 2. That would be -1. So that is it. So, but where the question comes most is the sum of oxidation number. The sum of oxidation, that number 8 and number 9. The sum of the oxidation number of all atoms in a neutral compound is 0. That is neutral compound. So, for example, if they ask you, let's say sulfuric acid, H2SO4, and they ask to calculate the oxidation number, the oxidation number is 0. Is that taken? Let's say they ask you to calculate the oxidation number of, no matter which one they ask, the oxidation of the total oxidation number of that compound. Once you are looking for the sum of the oxidation number of all the atoms in a neutral compound, that is, there's no charge, it is 0. And that's why we are equating everything to 0 when we are finding a component. But the second one is talking about polyatomic ion. For the polyatomic ion, the sum of the oxidation number of all atoms in a polygon is equal to the charge of the ion. It's equal to the charge of the ion. So let's say, for example, SO42 minus, for example. So, and they ask to calculate sulfur. So if you want to calculate sulfur, it will now be X. Maybe we are using X as like letter X or xylophone plus the base for oxygen is 4, right? That's 4 tenths. What's the charge of oxygen? We said it's always -2, except in peroxide. That's 4 times -2. So it will now be equals to -2. To be equals to the number of the charge. So it will no longer be equal to 0. So that would be X minus 8 equals -2. So X equals -2 plus 8. X equals 6. That means the same number of sulfur in SO42 minus is 6. Look at the example they gave us here. They said the oxidation number of P in H2PO4 is +5. Can somebody explain how it is +5? Or phosphorus? Anyone? This.
Okay, like this one, the whole this thing, the sum of, how did they even put that in English? The sum of oxidation number of all the atoms in this compound now is equals to -1 because it is carrying a charge of -1. So making P the subject of the formula, and with some hydrogen and oxygen. Wait, let me calculate it.
Okay, we are waiting.
But why are you laughing?
I want to say now.
Wait. 04 equals to -1 and times 2x plus x plus 2 times 4 equals to -1. 2 plus x plus 6 equals to -2 now. Minus 2 times 4
How do you say?
is -8. I said -2 times 4 is -8. -8 plus 2 is -6. I've done mistake. I don't know where the mistake is from. Oh.
Oh, Lillian, will you bail out? Lillian, are you there? Lillian? Titi? Is Titi still sleeping? Is our Titi back? Our Titi is not yet back. Oh. There's nobody to bail you out of your friend.
Try. It's not good, all of you.
Paul, is Paul there? Will you bail her? She's confused. Oh. Or I should bail her.
Okay, I've seen it. Then hydrogen plus -8, that is 2 plus -8 is -6. Crossing to the other side, it will now be +6. +6 minus 1 is equals to +5. So that's how we got +5.
Thank God you saw it. I believe you've not eaten this morning. So I understand. You've eaten, wow. That's good. Okay, so I believe you all understand how to calculate us. Lillian, you are not talking. Maybe I catch you. Don't worry. So let's move to other thing. Let me check the next topic. Balancing redox reaction. Balancing redox reaction or equations. So we have some rules here for balancing redox reaction. And I'll use one equation to explain the rules. So let's use zinc plus HNO3 nitric acid giving zinc NO2 plus 2 plus hydrogen gas. Now, the first step is that you need to assign oxidation numbers. Assign oxidation numbers. I'll just teach you very fast. Nothing much here at all. So what is the oxidation number of zinc? Zinc is what? Yeah. Zinc here is what? Please be fast now. Zinc is an element in its natural state now. So zinc is 0, Abi. Hello.
Yes, it is 0.
What is zinc here? In the product side. That's +2.
+2.
What about hydrogen? Hydrogen in nitric acid. What does hydrogen always have? Hydrogen in nitric acid is +1.
Is it 1 to 0?
1 to 0, yeah. Because this one is in natural state. What about nitrogen? Nitrogen and oxygen.
They are -1 together because they are radicals.
Which one?
Nitrogen and oxygen.
No, there's no change now. NO3 to NO2.
And now
Hydrogen
I'm saying they are radical, they are -1.
They are radicals, they are -1.
Yes.
Nitrogen and oxygen, the oxidation number is not changing here now. So they are 0.
Okay.
There's no change. Yeah.
Okay.
You can see finding the oxidation number of nitrogen here and the oxidation number of nitrogen here. There's no change at all. So N and O here has no change. Now the second thing, which is the step 2, after identifying your oxidation number, is to identify the oxidation and the reduction. Identify the oxidation and reduction. So which one is oxidation here? Anybody? Papa. Very fast. Hello, Lillian, are you there?
Hydrogen is oxidizing because it's losing electrons from 1 to 0, so it is reducing agent. Hydrogen.
Are you sure?
Yes.
Hydrogen is from +1 to 0 now.
It's oxidized. Loss of electron.
Who told you it's loss of electron? It's gaining electron now. +1 simply means it has lost 1 electron before. And now it has become 0, simply means it has gained.
Jesus. To this topic.
That is
I must conquer this topic, I swear.
I think the issue you're having is when you see +1. I told you when you see +1 on an ion, it simply means it has lost. Anytime you see plus does not mean it has gained. Plus means it has lost.
Okay, sir.
Do you get it now? So from +1 to 0 simply means hydrogen lost 1 electron before, but now it has 0. That means like it's not holding anybody, but it does not have extra electron. But for example, let's say you have 1 million, you are in debt of 1 million naira before. You owe me 1 million. Let's say you owe me 1 million naira. For you still owe me 1 million naira actually. But let's assume you owe me 1 million naira. And later you pay off the debt. you have nothing left with you. It's still positive because though you don't have money, but you're not owing anybody.
So
So
it's reduction.
so hydrogen plus to H2, like from +1 to 0, simply means hydrogen has gained an electron. Yeah.
Okay.
So that means it has been reduced. So it's undergoing reduction. Lillian, are you with us? Lillian, you're not participating, no. You're just giving me thumb up. I don't need your thumb up here. I need your voice. So look at zinc. Zinc from 0 to +2. That means it has lost electron. That's oxidation. Zinc here is 0. Later it became +2. It simply means it has lost 2 electrons. Please, do we get it? That's why I firstly taught you oxidation and reduction before we move to balancing redox reaction. So now, the next thing they ask us to do is to identify oxidation and reduction. So if we look at it, we can say zinc. We say zinc from 0 to +2 has undergo oxidation because it loses 2 electrons. If it is WAHEC, you write it has lost 2 electrons. And hydrogen from +1 gains 1 electron to become 0. That's reduction. Gains electron. Gift, do you get it? Oh, I should come again. Okay. So the next thing you need to do is to balance electron transfer, which is on step 3. You balance electron transfer. Now, if you want to balance electron transfer now, we said zinc loses how many electron? It loses 2 electron, I think. And we said hydrogen gain how many electron? We said hydrogen gain 1 electron. So we need to add 2. That is, we need 2 hydrogen in order to accept the 2 electron that the zinc is losing. Isn't it? So the step 4 would now be to balance the electron, to balance the atom. Hope you understand how we balance the electron. Zinc is the one that loses 2 electrons. It simply means hydrogen also has to gain 2 electrons because it has to accept the 2 electrons. Since zinc is losing 2 electrons, the number of electrons must be the same thing. So you multiply the smallest by the number of the highest. So since zinc has 2 electrons, 2e minus, the hydrogen will be 10 to 2. So that will give us 2e minus also. Do you get it? Lena, you do not get it. Do you understand that zinc loses 2 electrons, Abby? How many electrons does hydrogen gain? Look at hydrogen from +1 to 0. How many electrons does it gain like that?
1.
So now we need to make sure that the electrons are balanced. So if you have 2 and give us 1, how can we make it balanced? Is it not by giving you 1 more?
Yes.
So we multiply the one you have by 2. So you have 2 electrons and give to still have 2. Let's assume you have 2 before and give us like let me say 4. What we simply do is that you multiply your own electron by 2, that you have 4 electrons and give to still have 4 electrons. So we are adding 1 electron to hydrogen, or you are multiplying the one it has by 2, so that hydrogen can have 2 electrons and Zinc is losing 2 electrons, so hydrogen must gain the 2 electron to itself so that no electron will be lost. Do you now understand now? So the last one is you balance the atoms. You balance the atoms. So let's balance the atom. What was the atom they gave us? So that's zinc plus so we said zinc plus HNO3 giving zinc giving zinc NO3 base 2 plus hydrogen. Isn't it? So if you want to balance the atom now, we need to get 2H. Yeah, and if you want to get 2H, that means we need to add 2 to the nitric acid aspect to the reactant side. So it will no longer be HNO3 because we need to have 2H plus in order to have a balanced atom. So therefore, we are adding 2 to this to become 2HNO3, and every other things remain the same. So that means zinc here is 1, and zinc here, if you calculate it, must be 1. The hydrogen must be the same thing. The hydrogen here must be the same thing as the hydrogen here. The NO3 here must be the same as the the NO3 here. And that will give you a balanced equation. Is that taken? Should I do one more example before we move on? So you can see here that zinc lost 2 electrons, while hydrogen gained 2 electrons. Because your electron loss must be equal to the electron gain. And in case they ask you which one is your reducing agent and which one is your oxidizing agent, zinc is the reducing agent because it's the one that's been oxidized. Yeah, it's losing 2 electrons. Why your hydrogen is the oxidizing agent because it is gaining the electron. So the electron the hydrogen later gain is 2. So that's why we added to this agent of the this we all get it. Let me look for a typical example. I'm so sure Titi has left. Use just do Fe plus HCl plus FeCl2 plus H2. In case they ask you this one in the exam, just balance your equation straight and quickly find the oxidation and reduction. It is WAEC that needs all this calculation. Please don't waste your time. I'm just trying to do it step by step for you because you may need it when you get to your 100 level in your institution. Because they will still teach you this topic again for the science students, those that will be going for science courses. Quickly do this. What's the association number for iron? Let's be fast. This is 0. Minus 2. This plus 2.
Plus 2.
Yeah. How about hydrogen? Hydrogen hydrochloric acid.
Origin is
It's
plus
1
1 to 0.
to 0. What else? Cl.
Is minus 1 to
There's no change.
minus 1. Okay.
Okay. So let's identify the changes. This for hydrogen, this for iron. This step two said we should identify which one is oxidation or which one is reduction. So Fe has lost 2 electrons. Don't let me talk. Gift. Which one is oxidation? Which one is reduction? I think that aspect always confuses me. So let me ask you. A gift.
Iron is oxidation.
Why
It's
is it
losing two
oxidation?
electrons. It's losing 2 electrons to become +2.
Very good. So that's Fe from 0 to +2. So that's loses 2 electrons. So that's oxidation. And that means it's the reducing agent, in case they ask, isn't it gift? So hydrogen is from +1 to 0. That means it is gaining electron. Or it needs two, we multiply it by 2 against electrons. And that means it's going to undergo reduction. And in case it has, it's oxidizing agent. So if you are balancing the electron, if F is losing 2 electrons very fast, F is losing 2 electrons, simply means we add 2 to hydrogen so that it also can gain 2 electrons. You get that concept? So if you're adding 2 to hydrogen, so instead of we having Fe plus HCl, giving FeCl2 plus H2, since we are adding 2, so this will be for the balancing of atom. Do you all get it? Do we all get it? So you guys should do the third one. What I just want you to do here is to tell me uh the one that is undergoing oxidation and reducing agent, and what would be the balanced electrons, not atom, because you can just ask you. Can ask you for maybe silver. I don't know. I think silver should be the one. Don't let me see the answer. So tell me the one. Give me 1 minute. I want to run my generator. So this is the question. The oxidation, the reduction, the oxidizing agent, the reducing agent. Then you find out how to balance the electron. That's all. So we move to the next topic. Give me 1 minute. I want to open it. They honey, you have the money. Are you guys still doing it? Please let me try my power. Okay. Yeah. Are you guys still working on it? You are done. Okay. So gifts. Let me hear from the awesome out.
So copper from its
From what?
from the reactant side is uncombined, so it's 0. Moving to the product, it oxidizes and change to +2. Then silver,
So it lost how many electrons?
2.
Oh, it is undergoing oxidation or reduction.
Oxidation,
So is it reducing agent or oxidizing agent?
reducing agent.
Okay. What about this? Oh,
Then for silver, from the reactant side, it is +1. Going to the product side, it is 0. Is undergoing reduction. Therefore, it is a and it is an oxidizing agent.
do you know how to get A or an? If it's a
Eh?
full word, it is Anna.
Is an, yes.
Okay. So how many electrons is it gaining?
Is gaining 1.
So what will now happen in terms of balancing electrons?
When we are balancing it, we are going to add 2 electrons to silver trioxynitrate in the reactant side to make it balanced.
Silver trioxynitrate. Things like that.
That is after copper.
Silver nitrate.
Okay, silver nitrate. We are going to add 2 to it to make it balanced.
Very good. I think you guys are clear with that. So this is the logic here. In case in the example in your jam, and Lillian, I hope you get before I continue, please. Lillian, very good. Titi is still sleeping. I'm so sure. I hope you want to go and hand her call. I will reply to her. I will hand the call to her. So, what am I saying? I want to give you a tip. Okay. In case in the exam more, are you with me in your jump exam more? And they give you a formula name, probably an ion nomenclature. Let's say they say iron 2 chloride, and they ask you to find the oxidation number of iron. Please don't stress yourself. The Roman figure for that metal, it is the oxidation state of the metal. What did I say? The Roman numeral of that metal is the oxidation state of the metal. So in case they give you iron 3 chloride, which is FeCl3, don't calculate anything, just pick +3. Is that taken? In case they give you copper 1 oxide, which is Cu2O, the oxidation state of that metal, which is copper, it is what? It is 1. Do you get it? If they give you copper 2 oxide, it is CuO. The oxidation state of that metal is what? It is 2. Gift, do you get that? So you don't need to stress yourself calculating something. So that one is just 1 second's answer. Hope it is clear. Okay. So I believe now you understand. So Lillian, are you with me? Please, once you don't get it, always let me know, Lillian. Now I'm voting for
Can you come
you.
back again? Sorry.
Eh?
Can you come back again? I don't get you very well.
I'm trying to give you a tip for metal oxidation states. The alpha nomenclature using oxidation number. And actually, this is used basically for transition metals. So the format is that they will give you metal, they will give you the oxidation state, and they give you the anion. And I said anytime you see a question like that, it is a bonus question. Don't think at all, don't calculate it. The number, the Roman numeral that is attached to that metal is the oxidation state of the metal. Let me come again. The Roman number or Roman numeral of that metal that is attached to that metal is the oxidation state of that metal. Let's say, for example, that they give you, which one can I give you now? Let's say iron heavy chloride. So the oxidation number for iron there is 3. Without you calculating, you know, iron heavy chloride is FeCl3. If you are calculating oxidation number of iron, that would be X plus minus 1 times 3 minus 3 equals 0. X equals 0 plus 3. X equals 3. Do you get it? Let's say iron 2 chloride. Iron 2 chloride is FeCl2. That's X plus minus 1 times 2 equals 0. X equals minus 2 equals 0. X equals 0 plus 2. X equals 2. So without you stressing yourself, the Roman numeral of the metal is equivalent to the oxidation state of that metal. Do you get that?
Yes, sir.
So if they give you copper 1 oxide, for example, now, copper 1 oxide is Cu2O, and they ask you to calculate the oxidation number of copper. Instead of you stressing yourself, it is just 1. Just pick 1 in your answer. Don't need to calculate anything. If you want to calculate copper 1 oxide, Cu2O, so that would be 2x plus into bracket minus 2 equals 0, isn't it? That would be 2x equals 0 plus 2. That would be 2x equals 2. That would be x equals 2 divided by 2. That would be x equals 1. So instead of you going through all those jargons, just pick 1. You get the logic. So it is very straightforward. Yeah, thank you. So let's quickly move to another thing. I've taught you the oxidation numbers in every redox species. Anytime a species is putting electron, we say it is being oxidized, and we say that it's a reducing agent. So the role there is that any species that is being oxidized is the one performing the role of reduction. So we call it reducing agent. So anytime a species is gaining electron, we say it is being reduced, and it is doing the work of oxidizing. So we call it oxidizing agent. So that's just a summary of what we checked so far. So the next one is test for oxidation and reducing agents. Then we check few questions and answers. I think I gave you some questions already. Do well to submit it after the class. Submit it after the class. Titi, wake up. Titi, Titi, how many times have I called you? I've called you 3 times. If they call someone 3 times, she will respond. I've called you now.
Hear you.
I've been
hearing you since.
Thank God you are back. Our Titi is back.
I've been hearing you, but I don't want to.
Okay, me, don't want to talk. This is where. After the class, just go and sleep. Jeje. Is that the key? Yeah. So oxidizing agent. You can see my incantation work. I call her 3 times and she wake up. So heavy oxidizing agents, they turn potassium iodide solution brown. In case they ask you for. Another one is that they bleach colored substance. Please pay notes to these properties. They decolorize acidified KMNO4 and they remove oxygen from metal oxide. So these are the major questions that they will ask you. Here's the ask you for which of the following is an example of redox reaction. Let me just give you that. It's possible we move to another topic after now. For this one, roasting of iron, electrolysis, burning of fuels. Who is that? If I catch you. Respiration. Synthesis. So let's move to electrolysis. And this is the part that is it not TT that said she needs explanation on this part? And this one, TT is not active today. Sleep is warming her. What should I do now? Sleep is warming my TT. Okay, this is what we do. Let's quickly check first question first. Linear. Oh, linear. Now look at this 2010 question. Now, if you miss it, now what do you gain? Gifts. If you miss this question, what do you gain?
Look at, she even imported it along with the answer.
I've given you auto. Let me look for another question. Do you get this question? What they mean is this: zinc plus Cu2 plus giving zinc 2 plus Cu. But that's a stupid question, actually. Let me look for better question.
The answer of this one is A.
OJB. You know the meaning of OJB?
I don't know what is Ojebu Abi. What do you say?
When you say the answer is A, I mean, how will I say it in English now?
So, okay, sorry, it's not A. Oh.
Eh? What do you say?
What do you say? You said Ojebu Abi. What?
OJB. I say OJB. Like, what I mean is that when you said the answer, like, the question is too simple for you not to know the answer. Like, I'm not expecting anything lesser from you.
Is
Do
it
you get?
correct?
Are you still asking me? I'm supposed to stone yourself. Ask me if that is correct. I can't see a very hard question. Do you have any hard question in your job past question on oxidation and reduction? I'm trying to look for a question on my school, but the ones I'm seeing here is there's a question here. So which of the following is an oxidizing agent? A, carbon monoxide, CO. B, hydrogen gas, H2. C, zinc. D, potassium permanganate, KMNO4. What is it?
Sorry, I didn't get the question.
Which of the following is an oxidizing agent? A, CO. B, H2. C, zinc. D, KMNO4.
KMNO4.
And now I gave you examples of the actual example of oxidizing agents the other time. Yeah, KMNO4. The oxidation number of sulfur in H2SO4 is what?
It's +6.
In a redox reaction, the something that is reduced is what?
Ah?
In a redox reaction, the something that is reduced what?
It's oxidized. Oxidation. Antioxidant. I don't know how to say it.
In a redox reaction, the something that is reduced, A loses electron, gain electron, acts as an oxidation agent, decreases oxidation number. What's the answer?
Against the lecture.
Uh-huh. Well
So
done.
you know what you're doing. You're rushing it.
And now the question is too simple. You now see be I will not say be slow about it. What do you mean? I'm looking for a hard question, but I'm not seeing one. The oxidation number of chlorine in KClO3 is what? You calculate that.
That's +5.
Very good. I think this question is still good. 2020. Let me give you this one. I'm still part of this question to some extent. Which of the following reaction is a redox reaction? And tell me the reason.
Class C.
Paul. Are you Paul Agrippa? Do you know Paul Agrippa? Paul Agrippa in the scripture. The answer is C. Even looking at it, the first one is talking about acid and salt. That's neutralization reactions. That's salt and water. The general 3% is here. All these questions, well,
B.
B. Who said B?
Me.
Who said B? Me. Who is me?
Lily.
Lily. Lily
Yes.
flower.
Yes,
Or which
sir.
one? Are you Lily or Lillian? Are you not Lillian? Which one is Lily? Convince me that it is B.
Okay. It is B because an oxidizing agent is the one which gains electrons,
Are you sure? If not, convince me.
which is
You are just saying the same thing.
wait,
Oxidizing agent.
Let me be Bella.
okay,
Let me
wait, wait,
be.
wait. Okay, it gains electrons. That's it is being that's it when it gains electrons, it's being reduced, which making it an oxidizing agent.
Mhm. So an oxidizing agent is a species that is undergoing reduction. So it is being reduced. So this simply means it is gaining electron. Like I said, I really don't see any good question here that can.
Sir, there are questions, so not these old years. The ones I was seeing yesterday, they could
Can,
scatter somebody's brain.
on your jump past question, Abby,
Yes.
can you send it to the group after the class?
Okay, sir.
Let's do something maybe in the night. So let's check it together. Send jump questions. You can screenshot every jump question as much as you can on redox reactions. So give you to screenshot. I'm trying to look for questions still, Chef. And we have less than 13 minutes or 10 minutes to go. Let me look for more advanced questions. Okay, can you guys submit the answer to the question I asked you to the group now? Let's quickly do this together. So Gift, do the first one. Leon, do the second one. Paul, do the third one. Titi, do the fourth one. The fourth one says 2AL. Two AL plus 3 copper 2 plus, giving us 2AL 3 plus 3 copper. So tell us the oxidation, the reduction, the reducing agent, and oxidizing agent. Gifts.
Wait, I'm coming.
Okay.
Aluminium is oxidized, causing it to be the reducing agent. It lost 3 electrons,
Okay.
while copper is undergoing reduction, causing it to be oxidizing agent. It gained 2 electrons.
So if you want to balance it, how do you balance the electron?
It's balanced already because to make copper have 3 electrons, just like aluminium, they added 3 in the reactant side.
Assuming I did not balance it for you there. How do you tend to balance it?
Well, according to what you told us, you said that that since aluminium has 3, that we have to make copper to be 3. So we're going to add 3 to copper in the reactant side to make it balanced.
So according to what I told you, Hughes, don't
Mhm.
put me into quizzing. And now oxidation, aluminium, like we said, it is actually losing 3 electrons, and copper is gaining 2 electrons. So we want to have an even or the same number of electrons. So how do you do it? If we multiply aluminium by 2, it will give us 6. If we multiply copper by 3, it will give us 6. They get it now. So it will now be 6, 6. Is that taking? So that means we had 2 to aluminium side. That's why we have 2AL. And we had 3 to copper side. That's why we have 3Cu. Is that taking? So Lilian, over to you.
So I said I should do which one again?
What do you say?
Which one did you ask me to do? Is number 3, right?
Linear.
Sir?
SO2 plus Cl2 plus
No, it's
2H2.
number 3 I was doing, no.
Do number 2. Do number 2 and number 3.
And so why the 2 of them?
Since you've done number 3, yeah, now.
No fair. You have to do number 3.
So it's because maybe you number 3, do number 2. Yeah. Number 2.
So which one I should do? I should do number 2, I should do number 3.
What do you say? Do number 2 first, then number 3. Lilian?
So I've done number 3.
You've done number what?
Number 3.
You've done number 2.
Number 3.
Okay, Paul has done number 2.
Number 3.
Number 3.
No, now.
And now I said gift number 1.
What?
Lilian
What
number
you
2.
Number 3.
Paul number 3.
I thought
Now-
4 was number 3. No, sorry, number 2.
Lilian want to swap with Paul, and Paul is not agreeing. So Lilian do number 2. Yeah.
Okay.
Yeah,
Not fair.
it's fair or Nina. So it's unfair.
It's black, Jerry.
It's simple now. Who talk there? Is that Lillian friend?
It's me.
It's Gibbs Abby.
Yes.
I'll come and kidnap you. I will bring you to my place. I'll be feeding you. I know you like food actually. Yeah, Linia, what's the answer? Paul, what is the answer for number 3?
So iron is gaining electrons, so it's reduced.
Okay.
Then tin loses electrons, so it's oxidized.
So iron is oxidizing agent.
Yes, sir.
Very good. So how many electrons
Then
is iron losing or gaining?
iron loses one electron. Iron gains one electron.
Uh-huh.
Tin loses two electrons.
So how do you
So
balance it?
the net equation will have 4Fe3 plus Sn2 plus will give us 4Fe2 plus Sn4 plus.
SN4 plus. No.
It's 4 that is there on the other side.
Okay, 4Fe2 plus. No,
Yes.
actually, the normal equation is Fe3 plus SN2 plus giving Fe2 plus SN4 plus. So this is a balanced equation already.
Oh,
They get
I
it. So
thought
that's
this
why they
the
added
I
2
thought
to
this the
Fe3
original.
plus.
I thought this is the original equation.
So I think I copied the balanced one because if you had 4, no, we have 2Fe2 plus 2Fe2 plus 2Fe3 plus SN2 plus SN4 plus. This is balanced already. So
Okay.
linear, we are still waiting on. Or is it too hard for you?
Nope.
You can
So
call a friend or you can call me. I will bill you out. So you have to bribe me.
no problem.
Okay, now.
In the equation, sulfur loses electron,
Okay.
which is being
How many,
oxidized.
how many electron?
Huh?
How many electron?
Um, loses 6.
No,
See? Huh?
no.
2.
2, yeah. From +4 to +6. That's 2 now.
Yes, yes, so it's 2. So
Okay,
this is
so
electron, which is being oxidized, and it's a reducing agent.
very good.
And then chlorine gains 1 electron,
Okay.
which is being reduced and an oxidizing agent.
Clap for yourself, my girl.
Wait, then.
Yeah, that's good. So you guys please submit the work now, the assignment now on your book. So Paul, please don't forget to send in the questions. So that's I think I should be free in the night around 8 p.m.
Oh yes, sir.
We can do it together in the night. All right. So I actually paused the electrolysis because of Titi. She said she couldn't rest very well in the night, and she said she's having issue with electrolysis. So I didn't want to start at her back. So that's why I paused a little bit. So next class we will start with electrolysis. After electrolysis, we will do maybe organic chemistry. I think those are the 2 major topics that we make. And try to do it to cover the needful topics that remains for your time. So thank you guys. I'll be calling it a day. Yeah. Thank you for joining us. Let me stop the recording. Bye. uh